how ancient civilizations built massive structures without machines. The Great Pyramid is perfectly aligned with the Earth, but it was built 4,500 years ago, before compasses, before machines, before modern science. So how did humans achieve something we still struggle to explain? Stand in front of the Great Pyramid of Giza. Look up. Each stone weighs as much as a car. There are over 2 million of them, perfectly aligned, towering into the sky with mathematical precision. Now ask yourself one question. How? No cranes, no engines, no electricity. Just humans. The same fragile humans who struggle to lift a single heavy object today somehow built structures that still stand thousands of years later. This is not just history. This is one of the greatest engineering mysteries ever solved by the human mind. To truly understand this achievement, you need to forget everything you know about construction. No bulldozers, no steel beams, no concrete mixers. Ancient civilizations worked with what they had: stone, wood, rope, human strength. But what they lacked in tools, they made up for in intelligence. They understood something fundamental. You don't need power if you understand how to use it. The ancient world didn't have complex machines, but it had something even more powerful: simple machines. 3 tools changed everything: the lever, the inclined plane, the wedge. These weren't just tools, they were force multipliers. A lever allowed one person to lift what normally required many. A ramp turned vertical lifting into horizontal pulling. A wedge split massive stones with precision. These ideas may seem basic today, but at the time, they were revolutionary. This was the beginning of engineering. Before anything could be built, stone had to be shaped, and this is where things get even more incredible. Ancient workers used stone hammers, copper chisels, sand as an abrasive. Yes, sand. By rubbing sand between tools and stone, they could slowly grind through even hard materials like granite. It was slow, painfully slow, but it worked. And the result? Blocks so precisely cut that even today, a blade cannot fit between them. No cement, no glue, just perfection. Cutting stone was only half the challenge. The real problem? Moving it. Some stones weighed 50 tons or more. So how did they do it? Sledges, the first transport system. Workers placed stones on wooden sledges and dragged them across the ground. But dragging something that heavy creates massive friction. So they found a solution: water. By pouring water in front of the sled, they reduced friction, making the stone easier to move. It was simple physics, used thousands of years before physics was formally understood. Thousands of workers pulled ropes in synchronized motion, not randomly, but in rhythm, like a living engine. Recent discoveries show that these workers were not slaves, but skilled laborers, organized into teams, each with a specific role. This wasn't chaos. This was coordination on a massive scale. In Egypt, stones were transported using the Nile River. Blocks were loaded onto boats and floated to construction sites. Water did the heavy lifting. Nature became part of the machine. Once the stones arrived, they still had to be lifted, sometimes over 100 meters high. No cranes. So how did they do it? Ramps. Massive ramps were built using mud, brick, and stone. Workers dragged blocks up these ramps using ropes and sheer strength. Some ramps were straight. Others wrapped around structures in spirals. Recent evidence even shows systems of pulleys and wooden posts helping guide the stones upward. Slow, methodical, effective. This is how pyramids rose into the sky. Here's where the story becomes almost unbelievable. The Great Pyramid of Giza, one of the most iconic structures ever built, is aligned almost perfectly with the Earth's cardinal directions: north, south, east, and west. Even with today's advanced tools, Achieving such precision is a challenge. Yet ancient builders accomplished this without compasses, satellites, or digital instruments. Instead, they relied on careful observation and a deep understanding of the natural world. They studied the stars, tracking their movement across the night sky. By observing specific star alignments, they could determine true north with remarkable accuracy. During the day, they used shadows cast by the sun to measure angles and directions. Combined with simple geometry, these methods allowed them to map out structures with astonishing precision. This was not guesswork, it was science, practiced long before it was formally defined. These builders didn't just construct massive monuments, they created structures that were mathematically and astronomically aligned. They didn't just build big, they built perfectly. However, tools and knowledge alone were not enough. Behind every great structure was something less visible, but equally powerful: organization. Ancient civilizations mastered the art of coordination on a massive scale. Thousands of workers were needed to quarry, transport, and assemble materials, and each of these workers had to be supported. Food had to be provided, shelter arranged, and tasks carefully managed. Work was divided into specialized roles. The ancient Greeks took these ideas further, refining architecture into both a science and an art. They introduced columns, improved proportions, and focused on balance and symmetry. Their buildings were not only functional, but also aesthetically pleasing, reflecting a deeper understanding of structure and design. Then came the Romans, who revolutionized engineering. They introduced new materials and techniques, most notably concrete. This allowed them to build larger and more complex structures than ever before. The most important technology was not a tool, but the understanding of how to use it. Skills were passed down from master builders to apprentices, ensuring that each generation improved upon the last. Mistakes were not failures, they were lessons that led to better techniques and stronger structures. Over time, this accumulated knowledge made construction more efficient, more precise, and more ambitious. What ancient civilizations began has never truly stopped. Their simple machines evolved into more complex systems such as cranes, pulleys, and eventually mechanical engines. Their understanding of structure and balance became the foundation of modern engineering, architecture, and physics. Today's skyscrapers, though built with advanced materials and machinery, still rely on the same principles discovered thousands of years ago: balance, force distribution, and material strength. The tools have changed, but the ideas remain the same. Despite all these developments, one factor remains at the center of every achievement: the human element. Thousands of people work together, combining strength, creativity, and determination to bring these structures to life. Without machines, humans themselves became the machines. Their coordination, problem-solving abilities, and perseverance transformed raw materials into lasting monuments. In the end, the story of ancient construction is not just about tools or techniques. It is about people, their ability to think, adapt, and work together to overcome challenges. These structures stand as proof that even without advanced technology, human ingenuity is capable of achieving the extraordinary. If you want to uncover more hidden secrets of ancient civilizations, hit subscribe. This is just the beginning.